All right, welcome back. Today we're going to be doing tonic and phasic receptors. So how do we sense things in the environment? How do we know something's hot? How do we know if we're in pain? How do we know if we feel pressure somewhere? Well, we all use receptors. Our body uses receptors to detect things. There are two categories of sensory receptors. There are tonic receptors and phasic receptors. Now, they are probably located everywhere you can sense stuff. Maybe. The reason I say maybe, and I honestly don't know, is because I have personally not been in a lab and cut open a human and seen if there's these receptors at every single millimeter of the body. So I really don't know. Maybe there's research done if it is actually true or not. But you know how, science is. There's always that chance that, this is not true. And there's like one area of the body may not have it. I really don't know, but that's not important. For this video or, your test or whatever, just think about it as your hands or your arms or your legs, okay? Your skin, because that's where they're located. They are located there. So let's talk about tonic receptors first. Tonic receptors. So first, let's go over the picture here. This is our neuron, and then this is basically the receptor on the top. It's like the dendrite, for example. And we get a stimulus. Stimulus could be pressure, it could be pain, it could be temperature, it could be whatever it is. Tonic receptors. What's the reason for these receptors? Why do they exist? Well, they tell our brain how long the stimulus has been applied for. So let me explain it like this. Say you have been shot. I know this is a really extreme example, but honestly, this is the best example I can think of. Say you've been shot and you feel a lot of pain. But no, think about this. The pain is going to be there as long as the bullet is in you, correct? Forget about drugs. Forget you go to the hospital and they give you drugs and you don't worry about that. Just think about this. As long as the bullet is in there, you will feel pain. Think about if a bee stings you. As long as the stinger is in there, you're going to feel something. Okay? It is not until you pull that bullet out or that stinger out that the pain will stop. Right? You feel immediate relief. Assuming I've not been shot. But you get immediate relief. But you still feel pain as long as the stimulus, the bullet, or the stinger is still there. These are called slow adapting receptors. And the action potentials that this neuron is firing, so you say you got shot and that's our stimulus, this neuron is going to keep firing action potentials as long as the bullet's in there. Okay? This is what this action potential graph is showing. Every red little line is an action potential, and time is, as you go right, as time goes further. So notice in the beginning, we have a lot of action potentials firing. Oh man, this bullet hurts, right? It hurts, it hurts, it hurts. As time goes on, the receptor, the neuron is slowly adapting. It knows the bullet is still there. You're still going to feel pain, but it's going to kind of lessen. You won't feel as much pain. You will still feel it, but it'll be much less as time goes on. Notice it's slow adapting. We are slow to adapt to this. So we're here, and we notice we're getting more spread out. We're adapting to the stimulus, and it's getting further spaced out as time goes on. Okay. On the other hand, there are phasic receptors. Same kind of neuron, same deal. But what's the reason for these existing? These receptors tell the brain if there's a change in stimulus, also known as rapid adaptation. A good example are glasses, jewelry, or hats. And basically, the neuron stops firing action potentials upon constant stimulation. Let me give an example. If you wear glasses, you probably realize, or if you think about this, You wear glasses, and about a minute later, you don't feel the glasses on your face. You completely forget about it. You forget it's even there. If you wear a necklace or a ring, you feel right when you put it on, you'll feel it. But really, moments later, you completely forget about it. You don't even remember it's there, or you know it's there, but you don't feel anything on your finger. Or like a watch, you put your watch on, then you realize, oh, I can see my watch, but I don't really feel my watch on my hand, on my wrist rather. That's what I'm talking about. So notice the phasic receptors. We feel it immediately when you put something on, but shortly after, we don't. There's maybe one or two action potentials like reminding us we still have it there. Like you'll go out throughout the day and you're like, oh yeah, that's right, I still have my glasses on. That's what this is basically. We still feel it. But there's a huge gap you see here where we don't feel anything. You wear a hat. You don't really you go on for you go for a walk. You're not reminded that your hat is on your head the entire time. You don't feel it the entire time. That's what phasic is. It's rapid adapting. We notice it right away, and your receptors rapidly adapt, and we're like, we don't care about it. Another reason is our body has a lot of stuff going on. We don't need a lot of unnecessary inputs. We don't need a lot of things happening, going on. Just imagine, let me give you this scenario. Imagine you're wearing a necklace, a ring, a watch, a hat, like a belly button ring, a piercing, and a nose piercing. Imagine if all of those were tonic receptors. 24/7, you're going to feel those piercings, you're going to feel that hat, you're going to feel that watch all the time. And it's going to get annoying. You want to take it off. But luckily for us, there are phasic receptors, and we basically get used to it. We adapt to it, so we don't feel it. There's also a reason, for example, it's a good thing we have tonic receptors. You're like wondering why shouldn't we all have phasic receptors? Isn't that a good thing? Well, no. Tonic receptors are a super good thing. Because imagine this. You really do imagine you actually got shot. And you leave that bullet in there, and then you feel no pain. But the bullet's still in there. It's still going to cause damage. You'll probably just completely forget about it, which is not a good thing. In a real life, you won't really forget about it, but you know what I mean, right? If there's something wrong with your body, it's actually a good thing you have pain in your body, so you know there's something wrong. If you just got used to that pain, if you just got adapted to that pain, you'll never know what's wrong. Let me give you another example. If you have appendicitis, for example, appendicitis hurts. I've not had it myself. I don't have my appendix, but people who have had appendicitis, it hurts like a lot. Imagine if you just felt the pain for about like 5 minutes and then just went away, right? Imagine if there were phasic receptors and they just went away after like 5 minutes. How would you know you're having appendicitis if the pain just went away after 5 minutes later? You would die. People die from appendicitis because infection spreads. Luckily, we have tonic receptors. As long as something's wrong with the appendix, we're gonna feel something until it's fixed. That's why you go to the doctor, and that's how things are solved. Imagine if you had a heart attack. If the pain just went away 5 minutes later or 2 minutes later, how would you know you had a heart attack? You're gonna die. So that's why it's really important you have these two types of receptors. They're both good, but they have their reasons of being good. I hope you found this lecture concept overview helpful. Please like and subscribe. I found a lot of my fellow classmates when I took physiology found this topic really confusing, and they're like, I don't know the difference. They still don't know the difference. But hopefully I explain it in a way that it makes it so much more easier. That's my goal. But anyways, until tomorrow. Later.